Good morning, guys. Today we are back with another problem. Today's problem is a problem of minimum number of steps to reach a destination. So what you can see is like there is a first I'm going to go through a problem walkthrough. Before that, I'm going to explain what is there in the question. So if you see in the question that we will be given an infinite number line. Okay. So what is the number line? So a number line which starts from negative to positive to 0 to positive. So it's like an integer number line. We can assume this is an integer number line. Yes. So you can start at 0 and you can go either left or right. Okay. So means you can go towards the negative or you can go towards the positive. So since a number line, it can be positive and negative. The condition is that the ith move, you must take I steps given a destination D. Find the minimum number of steps to required to reach such destination. So you can see if and if D is there, so you can take the minimum number of steps to reach D. So let us take example 2 and let me explain the example 2. Okay. So first what I'm going to do is first let me write the problem. So yeah. So the problem is minimum number of steps to say reach our destination. So let's just say, for example, uh, we take a number line over here. So say for example our number line is like this, and this is where somewhere our 0 lies. Okay, and we can either go towards the left. Okay, so you can write over here, say for example -5, -4, -3, -2, and -1. And like coming over here, you can write 1, 2, 3, 4, 5, or you can, yeah. So the problem tells is you can either go right from this point. So you can write over here, I can either go right or I can go either here over here as left. Okay, so I can either move left steps and over here as sum. So this is the required line between the steps and the sum. So for the first step, say for example you are moving from say for example initially the steps is 0, and initially the sum is also 0, right? But say for example the user gives d equals to 10, which is our example. So how are we going to reach that particular destination? So in order to reach particular destination, first is our steps. So first we will be 0, the sum will be 0. Okay, so let's take for step 1. So if it is step 1, the sum will be like, add the sum will be 1. For step 2, what we can see is we have to add 2 and the sum will be 2 plus 1, which is 3. For step 3, it will be 3 plus 3, which is 4. And for step 4, we can see it is you can see 3 plus 3, sorry, this will be 6. So we can see 6 plus 4 equals to 10. So at step equals to 4, we can reach the sum as 10, or d equals to 10. So you have to be very careful. So this is the problem over here. You can either move left or right. So also the time complexity they're demanding is a big O of 1, minimum number of steps. We're taking the distance. As I told, we have to take the sums, and then we have to run a loop until the sum becomes less than or equals to the destination. Then we have to increase the step count and further add the steps to the sum, and we have to return the number of steps, because we have to return the number of steps which actually took to reach to that particular destination. Okay, so what I can do is over here, I have to write int steps equals to 0, int sum equals to 0. I can write while my steps I can say less than my sum less than d. What I can do is I can write like this as steps plus plus sum plus equals to steps, and finally return the number of steps. So return steps. Yeah. So this. So yeah. So let me just run this solution. So it's a pretty easy problem. I don't know why they gave it under a medium category problem. Oh, so you can see that we have encountered a problem, time complexity problem. So for this problem, we can see that our code output is 18 and its correct output is for input 160. So we have to think of inputs which are really large. For bigger values of n, or for bigger values of the distance, we have to take the condition over here. We have to take a condition that if the sum surpasses the destination by an even number of steps. So you can write it over here, if sum surpasses, you can write it over here, if sum surpasses the destination by even number of steps. The same thing what we did in this while loop we are going to do over here, and we are going to return the steps. But over here the condition was if the sum value is lesser than the destination. But there will be some cases where the sum value gets more than the destination, right? So in that case, what we are going to do, we are going to take steps plus plus, and the same logic we are going to do, but we are going to calculate the sum minus t. It is the difference between the distance between the summation and the distance which we have recrossed, and the actual distance modulus 2, and which basically says that we have to take even number of steps, right, in order to give better time complexity. So this was today's problem, and hope you understood the particular problem.